Hey guys, this is Somdev Basu, just another folk who finds deep learning rather fascinating. I'm currently an ML research intern at Team Cognito. I'm also a contributor to the Spotify recommendation engine and DS Algo notes for Gulf Script Summer of Code. Besides, I'm a regular contributor to the open source community and an active member of various societies in the city, such as GDG Kolkata, Facebook Developer Circles, etc. My primary interest lies in working on computer vision, generative models, image segmentation, and more recently, generative adversarial networks. Right now, I'm just going to talk about one of the projects that I made. And this was basically a challenge to integrate NASA data, the ground based air quality data, as well as user input crowdsourced data to find out the most optimized algorithm to generate this and find out an API for making it possible for the user to find out the most predictable data for a particular location at a particular time. So these are the various data sources that we used. Now, there was a real-time data that we used here because the NASA data for air pollution was in fact real-time. And we had to use a best suited data algorithm for plotting it on a graph. Because this was a real-time data, therefore it posed a significant amount of distress to us. After plotting our data and finding out the optimization parameters, we finally found out the geolocation of the several hotspots as we identified and then plotted it on Google Maps. We used, as I said, data from 6 different API sources, and finally, after applying the optimization factor, led to the creation of our API. So these were the various optimization graphs that we obtained while training our algorithm, machine learning algorithm that was basically a recurrent neural network. So as you might have imagined, the air quality index of a particular place isn't very well determined by a particular set of factors. It is different for various places, and therefore it was important for us to weight in the several parameters and apply dimension reduction via the implementation of support vector machine. Now, since there was a runtime data, there were officially two backlogs because of using recurrent neural networks, which was the vanishing gradient problem and the time lag. This was eventually overcome by using LSTM. So this allowed us for the continuous plotting of our data on Google Maps using gmplot as well as Google Maps API. So as we trained the LSTM model, as you can see, the accuracy continuously improved over the epochs while the error rate decreased. So revenue generation was made possible by creation of our optimized API as well as our optimized data set, which was a paid one. This optimized data that we obtained had a lot more accuracy, and this accuracy was actually limited to 0.1 degrees because of the natural unavailability of data from NASA as well as the several other sources that we used. And for decreasing its time complexity, our LSTM model almost took 8 hours to train, especially because it was real-time data. So as of now, the UI design of our web app looks like this, but we hope for a better UI design. We are thinking of it and would definitely improve it in our future prospects. Thank you.